Cisco SD-Access, software-defined access. What's going on? This is NetMaven. SDA is an intended-based network solution, provides a secure and a scalable network which is fully automated and decouples the network functionalities from the hardware and creates a virtual overlay over the underlying physical network infrastructure. The SD-Access also enforces consistent policies across the enterprise to both the wires and the wireless, preventing unauthorized access just by containing the breaches. So this solution helps the IT service by reducing the operational expenses, and it will enable them to faster solution times. So although Cisco SDA is available since DNAC C 1.0 release, the latest version provides the more advanced capabilities by simplifying underneath the architecture using the Lisp. So what you see these things right now is called Cisco Catalyst Center solution. In the pub and sub Lisp architecture, the control plane nodes are publishers and border devices are subscribers. Well, say this is the control plane. We're using this Lisp. Right here, you see is the control plane. It's my publisher in Lisp. These border were the subscribers in Lisp. Okay. The border nodes, that border device here, where the border subscribers, the both local control plane nodes and transit control plane nodes, depending on the single site or the multi-site fabric design. This new architecture also adds more advanced Lisp features like a border convergence using the dynamic default border, backup internet. Pub and sub in this design also eliminates the need of running BGP between the control plane and the border, transit control plane and the border. We will walk you through the lab using the fabric sites and the virtual network provisional and new pub and sub architecture. This is the configuration we'll walk you through, and the dynamic default border with this Lisp pub and sub. There's active backup remote internet with a pub and sub. This is the diagram we use for physical topology. This lab consists of multiple fabric sites, as shown in earlier in here, the logical virtual topology. We have is the border control in the campus site and edge 1, 2, 3 edge device, and we have a border, my border in the DC site. Okay, control plane also. I have branch site, fabric in a box, FIAB. Okay, that's the whole thing about my topology. This is the virtual, this the physical. Okay, just take a look of this, download if you want. The whole app we're using Catalyst 9000. Software version is 17.12. We do have a fusion switch right here. The fusion switch is Catalyst 8000, running version 17.9.4. Also, we have the drum post, we have a DNAC, we have an IcePan, we have a server for AD, DSCP, DNS, and CA. We have a wireless controller, WLC, that's 9800 CL. Just to follow along my lab, you will get to know all the subnet ranges of the IP we use, it all gonna take steps. So first, we'll run a task. That's day 0. We're going to manage the network with the DNAC center. We'll start the discovery tool to discover and add existing network devices in the network. And we have the necessary IP address, range, credentials needed for discovery. Are already added part of the DNAC center base configuration for this lab. Go ahead, log into my lovely DNAC. We call it the Headless Center right now, and we're going to go to Tools and run Discovery. From the Discovery dashboard, we should see all Discovery devices. We have Fusion Router, Fusion Controller, Fabric Controller, Fabric devices. They all predefined discoveries. Now we'll have to run first to do a discovery of the Fabric devices, part of the network. The total, we have 9 Fabric devices, needs to discover using CLI and CSNMP. Okay, click Discovery. Give a new tab to see what's discovering. I'm pausing my video until I'm gonna show you all the device discovered. Alright, the discoveries come down and view discovery. Here you go, we have discovered a few devices. We'll go to provisioning, inventory. And these devices have been synchronizing. All right, we will continue to discover more device. We're going to run the Fabric controller discovery. Okay, Fabric controller discovery is done. Then we're gonna run to discover Fusion discovery. Fresh. Now Fusion discovery completed. Back to my inventory. Let's see what we discovered. We discovered the Fusion router, data center, control plane and border node, and I discovered campus, edge device 1, 2, 3, edge switches, campus, control plane, campus border 1, border 2, and I have a controller C9800. I have a Fabric in a box at the branch site 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have is wireless controller. So total we have is 11. So let's go to design. We should go over some design. Okay, so DNAC will provide a robust design application to allow the customers of various sizes and scales to easily define their physical size and common resources. The design application uses a hierarchical format for intuitive use, where just eliminating the need to redefine the same resource in multiple places when provisioning sites. By default, there's one site we call it global. You can add more sites, buildings, and areas to your network hierarchy. Here we have a New York branch is an area, and our building is New York 03 and floor 6. So you must create at least one site before creating the fabric site. So most of these network devices needed buildings and or floors for site assignments, and provisioning the wireless APs need floors. The network hierarchy is created part of the lab already did. We have New York, San Diego, San Jose HQ. They have building, floor, building, and 2 floors in San Jose. So let's verify the network hierarchy. The behavior of our DNAC is to inherit the settings from the higher levels into the subsequent levels of hierarchy. These settings are located in the network settings. First, global settings. Enable, so this way, the hierarchy will enable consistent across large domains. We're also giving the customer, the administrator, the flexibility to adapt and change for a local area. That's the building and floors. So to begin, we are going to find our architecture. So that's hierarchy. In the entire site, we have 3 ones. And go to the network settings. The DNAC saves common network resources settings in the section network settings. Under we have it called design, and we described earlier, and it is allowed in the information to store and later reuse throughout the DNAC workflow. So design here we have defined 2 IP pool. They are generic. They're not here to be used. They're being to be as reserved. So we have a border that's 192.168.200.0/24, and it's global 172.16.0.0/16. Servers, we define DHCP, we define DNS, domain name, and DNS. They're the same server. Under credentials, the credentials we have, we should click and manage credentials. We don't have many credentials. We will assign no SM3, save. Manage credentials, we have CLI, SMTP2, read, SMTP2, write. Close. Talk about, again, IP pools. On the global, the IP pools are created at a global level and then reserved within a site. So IP address pool can be created in a global as a larger network. For example, we have a /16/25, right? And for example, if you reserve like 24, it can be reserved in the site levels as a smaller subnet. So DNAC uses the IP addresses from the reserved IP address pools for various uses. So DNAC supports both manual IP address allotment, or you can integrate with an IPAN solution such as InfoBlocks to learn the existing IP address pools already in use. Just remember, the DNAC isn't an IP address management system. The border handoff pool is used for the P2P links for VN handoff. The overlay pool is to associate with VN and VIFs, and then create the anycast gateway for each VN and DHCP helper addresses on each edge switch. Aside from the address used by the end client, the underlay pool is for the LAN automation and wireless access points. In this lab, the IP address pools are pre-configured in DNAC, so both at the global level and site level. I will show you. Now, we defined global IP pool, layer genetic pool for reserve, and now we could reserve, for example, New York branch, and New York 03. We'll click any site on here left to see the reserved IP address pools. So these pools are reserved as a part of DNAC center-based configuration. Remember these 172 and 16 address subnets? They are the global under global pool. Okay. Following that, you can see the flow is inheriting what we have from the building. The reserving for AP, BMS, wires and wireless for New York 03. Now check San Diego. We have reserved San Diego and San Jose for their own pools. They have pools for the border handoff, and they have pools for border handoff in San Jose as well. The next thing we'll do is to assign network devices to a site. The DNAC center includes the initial steps as the part of the device provisioning. To simplify the overall workflow, just also we'll have to apply this non-fabric support as we DNAC can also push the site specific configuration to devices that are being used in the fabric. The site assignment uses the network settings configuration, or called template editor, topology assurance. As the access deployments, this part is taken care of during the provisioning of the network devices. So this app isn't needed in an SDA lab. SDA access only requires the fabric nodes to be provisioned to a site, although other devices such as the intermediate nodes and the fusion routers can be provisioned or customized with configuration defined in the templates editor. They aren't required, although. The next few steps provision the network device with the network settings configuration that we assigned in the device section. So this is a prerequisite for devices in SDA. Also, we need to enable netconf for both the 9800 CL and the fabric in a box devices, which are going to run the fabric enabled wireless. So on the DNAC, we'll go navigate to the provision, find the inventory. All devices are under global unassigned devices now, and we're going to select the CPS. Apply. We're selecting the CPS border 1, border 2, FE3, and CP from the global. And we're going to select provision, action inventory or provision device, and we'll assign all to San Jose HQ as JC04. Save. The DNAC provisions similar devices at the same time. So at above the two devices that are from the Cisco Catalyst 9300s product families, and since the device that are 9300 provisioning time is longer than hardware-based 9300s, we are using virtual. Click next and go the summary page. We'll have to click next, close, click apply. All right. Next. Let's wait. Click the deploy. Submit. Okay, let's take a look at the task. We have to see the provision failure for CPS campus border 1, campus border 2, and edge FE3 is because the PKS, I think is PKS 12 certificate. It is due to the platform limitation and will not impact the lab. Okay. Go back to the inventory, refresh. We can see we have assigned this device to SJC04. Now we're gonna just select FE1 and we'll make a provision. Select the site, San Jose, SJC04, throw 1, save, next, next, apply, next. Now click OK, deploy. And find FE2 edge 2, assign, not assign. We want to provision. Assign to site, San Jose, throw 2. Save, next, next, next. Next. Deploy. Refresh. Now with the two tasks have been deployed in progress. Refresh. Back to inventory, cancel this. Let's now click the setting knob. Let's edit table column. We'll find is the device role. Is showing up. Good. Find the device role. Well then, find a device CPI campus FE3 to be access. Because right now it looks like a core. So I change the role to be access. Save. All right. On my task, they ran successfully. Later, we'll select DC border and DC control plane switches. These two. For the global side, and we're gonna choose select the provision device. These two will be assigned to San Diego SD-02. Save. Next. Next. Click OK. That's fine. Deploy. Refresh. Now go back to inventory and we're going to just select the fusion switch. Fusion switch and provision and assign to San Diego SD-02. Deploy it. Now new deployment in progress. Take a look at the Paris one. It's because the saying, okay, ignore this. Go back to inventory. We have a last one. That would be my fabric in a box. Provision only to New York branch. Save. Deploy. Refresh the task. All right.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.